To compare the fuel availability for kerosene and gasoline is that they both depend on supply and demand. They both are made from crude oil, and crude oil resources are abundant because the oil itself is becoming insufficient. Refineries play a part in the amount of gasoline available on the market. There is only a limited capacity for refining crude oil. Companies are less likely to invest in new refineries when crude oil prices are too low. Besides, high exchange rate affects the scarcity of kerosene. There is a shortage of foreign exchange for suppliers to import kerosene, therefore why kerosene is expensive. In other words, the amount of gasoline are limited by investors who want to invest in new refineries for crude oil, and suppliers cannot import kerosene because of foreign exchange. Therefore, kerosene and gasoline depend on supply and demand.
Internal combustion engine do notable harm to environment. Internal combustion engines are by law required in developed countries to emit exhaust gases which contain very low levels of particulate matter, carbon monoxide, unburned fuel, and oxide of nitrogen. Big cities in developed countries are badly affected. Carbon monoxide which come out from the engine is poisonous and for sure give bad impact on environment. Continuous growth of emission of pollution substance by motor transport become the main problem of pollution of the atmosphere of the city in recent years. Growth of number of automobile and lorries, buses in recent years, objective difficulties in providing an effective traffic on the city. And this all appears automobile jams. All this is one of the major defining factors in being observed decrease in quality of atmospheric air and increase in its pollution. Aircraft exhaust emissions which occur as a result of combustion gather at atmosphere where various greenhouse gas located, thus be the cause of global warming. The exhaust emissions of an aircraft engine can be listed as carbon dioxide, H2O, Hc, NOx, sulfur oxide.
Power to weight ratio or specific power or power to mass ratio is commonly applied to engine and mobile power source to enable the comparison of one unit or design to another. Power to weight ratio is a measurement of actual performance of any engine or power source. It is used as measurement of performance of a vehicle, with the engine power output being divided by the weight of the vehicle to give metric that is independent of vehicle size. Simple logic, more weight requires more power to pull it. As for gas turbine is powerful than automotive internal combustion engine because of its larger size, but the weight is lighter. This is why aircraft use this gas turbine engine to give more power output. A gas turbine engine can process large amount of gas in a small engine, resulting in high power weight ratio.
In automobile, the engine only requires smaller space, thus it is used to power most type of automobile vehicles. It is also obvious that internal engines used for car cannot be used as helicopter engine or any aircraft engine, for instance, since more power is needed for heavy transport like that. Major components of the common internal combustion engines only includes small parts like cylinder block, exhaust system, valve train, and cooling system. Therefore, it don't need that much of a big space to store it in the vehicle. Next, for gas turbine, which is used mostly in the aircraft. Gas turbine engine has a very different build compared to the internal combustion engine in terms of the size of the engine components. This includes the size of compressors, turbines, and combustion chambers. So basically, the space requirement for gas turbine engines will be bigger. The size for gas turbine engine is like 2 cubic meters and weigh about 5,000 kilograms. Because of the components for gas turbine engine are big in size, it is impractical to be used as automobile engine.
Explain a little bit about the comparison of performance between Otto and gas turbine. So gas turbine have a little better peak cycle efficiency as shown. Gas turbine are Brayton cycle, internal cycle engine, or sometimes Atkinson. Carnot is the theoretical maximum for any heat engine. So this cycle is for Otto. The real gas efficiency is 58%, For the diesel is 62%, Atkinson is 67%, for Brayton or gas turbine engine is 70%, and for the Carnot is 90%. So the efficiency varies strongly with rating. 100 horsepower engine will invariably have higher efficiency than a 10 horsepower engine. Gas turbines are expensive for their rating and are therefore generally relatively powerful. Similarly, a 120 megawatt gas turbine is far more efficient at full power, that is approximately more than 45% than a 200 horsepower or approximately 150 kilowatt automobile internal engine at full power, 20%. Comparing the efficiency of a 120 megawatt gas turbine to an automobile internal combustion engine is an inappropriate measure to the basic efficiency of cycle.